Hello, and welcome to AHA-VTS Clipcast on Basic RIP Setup. My name is Alim H. And oh, by the way, I'm this handsome gentleman to the right. It's a cold day in New York City with about 18 inches of snow, and I decided to produce another Clipcast since most of us really don't need to leave our beds, and probably you guys are eager for another one of my IT topics, right? Well, this one is about RIP Basic Setup. So as network professionals, we configure many routing protocols and also static routes. But there is one routing protocol that is still being used today in small networks and, believe it or not, on our broadband routers that connect us to the internet, even though this routing protocol may seem to be obsolete. And that is RIP, which stands for Router Information Protocol. Well, in this clipcast, we're going to briefly discuss what RIP is, and we're going to configure RIP routing on a few devices as shown in the diagram below. So, let's get started. So what is RIP? Well, as I said a few minutes ago, RIP stands for Router Information Protocol and is one of a few dynamic routing protocols which are used on LAN and WAN networks. And RIP comes in three flavors. The first one is RIP version 1, which contains no subnet mask information and thus can only do classful routing. Then we have RIP version 2, which is an enhancement of RIP version 1 that does include subnet information for classless routing, or CIDR, which is classless interdomain routing, and also contains MD5 authentication. And last we have RIP NG, which stands for RIP Next Generation, that extends the RIP version 2 to include IP version 6. But no matter what flavor you're using, RIP's administrative distance is 120 and it uses hop counts as its metric to determine how far a destination network is from the source. But in this clipcast, we're going to configure RIP version 2 since it's still prevalent on networks and also part of the CCENT CCNA courseware. Now in the diagram shown below, I have a small LAN network that consists of two routers and a switch, with each router connected to the switch via a fast Ethernet link. And I've already configured the IP addresses of these interfaces that connect from the router to the switch, as well as a few loopback addresses to simulate live routing networks for the purpose of illustrating RIP routing. So the first thing I'm going to do is call up my term prompt, and we are already on router 1. First thing I'm going to do is do a show IP interface brief to get myself orientated and to see the interfaces that I want to put into the RIP routing process. Now in order to configure RIP, we have to get into config T mode or configuration terminal mode. Then type in router RIP followed by, well, the first thing we're going to do is configure the version that we're going to use, and this will be version 2, followed by the network command to put our networks that we want to use in the RIP routing process. First I'm going to add is 100. That's the network between router 1 and switch 1. Then our loopback addresses. First one is the 10, followed by the 20, followed by the 30, and last 40. Then I'm going to do a show IP route. Give those a few seconds for the RIP process to configure. And as you can see, on switch 1, I've already configured the RIP routing between the switch and the networks between router 1 and router 2. So that's where the 192.168.0 comes from. So we have the RIP routing process working, and I'm going to go on router 2 to do the same thing. But first, let's do a quick ping of one of the loopback addresses on router 2 just to prove that we can't get there. So I'm going to do the 50.50.50.1, which is one of the loopback addresses. And when we do the ping, and we can see that it's going to time out, so we definitely know it's not going to make it there. Okay. And we end there. Now I'm going to jump on router 2 to configure the RIP process there. Okay, I'm on router 2. The first thing I'm going to do is do a show IP interface brief to get myself situated again. We see we have our fast Ethernet and our loopback addresses. Just the same thing we're going to do that we did on router 1. Go to config T if I could type it in correctly. Of course I can't type. The first thing is router RIP, followed by the networks that we want to place into the RIP routing process. This one is 192.168.0.0, for the interface or the network between router 2 and switch 1. Then our loopback addresses be 50 at 0, followed by 60, followed by 70, oops, sorry, 70, followed by 80, and we are there. So let's do a show IP route. Let's see what we have in this routing table. Notice we have all of the RIP routes that is coming from router 1. And to validate that, as you can see, the first one is the 100 network. That is the network that exists between router 1 and switch 1. And you notice also we have the 10, the 20, the 30, and the 40 networks that represent the loopback addresses on router 1. So in order to test that we can get there, let's do a ping. Let's do a ping on the 20, that 20, that 20.1, and see if we get there. And lo and behold, we do get there from router 2. So looking at this IP routing table, remember I discussed about administrative distance and hop count as this metric? Let's take a look at the 10 network. You notice you have the 120 and the /2 in the square brackets. The 120, as I mentioned earlier, is the administrative distance or the trustworthiness of the route for the routing process. And the 2 is the number of hops that you need to go in order to get to that destination network. So in order to prove that, let me have my diagram here. From router 2, in order to get to that network, it would have to make one hop from router 2 to switch 1, and then another hop from switch 1 to router 1 in order to get to that destination network. In order to prove that, again, a second time, let's do a trace route. So we're going to do a trace route on the 20 at 20, the 20.1, to determine the number of hops that it takes or number of devices that it must pass through in order to get to there. And lo and behold, when we do the trace route, we see that it goes through the 192.168 network and then from the 100.100.100 network in order to get to the 20.20.20 network. So the last thing I'm going to do is show IP protocol to take a closer look at the RIP routing. And if we scroll to the top a little bit, we are routing for RIP, and updates are sent every 30 seconds, and the next one is due in 13 seconds. Invalid after 180 seconds with a hold down of 180 seconds and a flush out after 240 seconds. We'll also notice that the interfaces are sending RIP version 1, but receiving either RIP version 1 or RIP version 2. And is routing for the networks 50, the 50 network, the 60 network, the 70 and 80 networks, which are loopback addresses, as well as the 192.168 network, which connects between router 2 and switch 1. And the gateway is the 192.168.0.1, which is the interface of switch 1 connected to router 2. Well, let's recap. Well, we talked about who's the host of this Clipcast, and is Alim H. I gave you a brief introduction to what RIP is, as well as configuring the RIP routing for the network shown below. Of course, I didn't go into great detail about RIP itself, the history, and also about dynamic and static routing. But you can visit AHA-VTS.com and look out for future flicks, clips, and Clipcast on these topics and much, much more. I hope this Clipcast on basic RIP setup was informative, and I'd like to thank you for viewing.